Alright, this is our lesson on radians. What you need to know about radians is right down here. Radian measure is essentially the exact same thing as angle measure. It's just a different way of talking about it. So it's almost like if you think about how temperature can be measured in Celsius and Fahrenheit, which are two different systems, we can also measure angles in degrees as well as radians. So what we end up finding after we complete 1 through 4 is that 90 degrees, what we're always used to calling 90 degrees, and actually, let me write that out, 90 degrees, is actually equivalent to pi over 2 radians. I don't know of a cool symbol like the little 0 for degrees that exists for radians, but I don't think there is a symbol. I think it's just pi over 2. So what happens if you complete 1 through 4 is you end up finding the ratio of the length of this arc here to the radius. So think about it, arc length over radius. A ratio is going to be when you divide one thing by the other. So for the first one, let's say I find the arc length. So PQ, the arc PQ is going to be equal to 90 over 360 times 24 pi. So I guess over here to the side, you guys need to know that arc length is equal to angle in degrees over 360 times the circumference of the circle. Now the circumference, remember, is 2 times pi times the radius. Oh, sorry about that. Okay, so I can go ahead and do a little bit of cross-canceling. 90 and 30, 60 will reduce to 1/4. 4 will reduce with 24 to 6. So I get that PQ, arc PQ, the length of it, is equal to 6 pi. Now, PQ over the radius is equal to 6 pi over 12, because 12 is our radius. And that ends up reducing down to pi over 2. Then they ask us to, instead of having it be 12 centimeters, they have us pretend that this is now 9 centimeters. So the only thing that's going to change out of this equation over here is now I'm going to have to do, it's still going to be 90 over 360, but I'm going to be multiplying by 18 pi instead of by 24 pi. Because remember, the radius is 9, so that's halfway across, so the diameter would be 18. So 2 times the radius times pi, or pi times the diameter, depending on how you want to think about it. Okay, so I can reduce 90 over 360 is 1/4, and then 18 over 4 will reduce to 9 and 2. So I get 9 pi over 2 is my arc length, and then to get the ratio, I'm going to do 9 pi over 2 divided by 9. Now if you remember, when you divide, it's the same thing as multiplying by the reciprocal. So I could have 9 pi over 2 times 1/9, where these will cancel, and I just get pi over 2 for the ratio, which is the same ratio I got up there. If I choose another length for the radius, I don't know, I'm going to make the radius equal to 6. It would be 90 over 360 times 12 pi. 12 pi because that's the circumference times, that's the circumference, which is the diameter times pi. So 90 over 360 is 1/4. 4 cancels out with 12. I get 3. So I just get 3 pi. And then for the ratio, I would do 3 pi over 6, which ends up being pi over 2 again. So every single time, for any circle, the ratio of the length of the arc intercepted by 90 to the radius will always be pi over 2. And this is because all circles are similar. So the radius will always end up having the same ratio with the arc length because you're comparing the liney part. Alright, so basically what that ends up meaning is that we can find not only the ratio for all the 90 degrees, We can find the ratio for anything. So because we can keep finding the ratio for any degree, we actually call it something, and we call it the radian measure. I'll continue the rest of it on another video.